You press a button. A gentle hum follows. Water swirls, the drum spins, and in under an hour, your dirty clothes come out clean and fresh. But have you ever wondered what's actually happening inside that big metal box humming in your laundry room? Your washing machine might seem simple on the outside, but under the hood, it's a mechanical and electrical masterpiece, an engineering marvel hiding in plain sight. It combines hydraulics, electronics, software algorithms, mechanical timing, and even a bit of physics wizardry. Today, we're diving deep into the brain and brawn of your washing machine, the hidden genius that scrubs your clothes cleaner than human hands ever could. Let's start where it all begins, the control panel. That innocent-looking array of buttons and knobs is more than just user input. It's your direct link to the machine's CPU, the central processing unit, also known as the main control board. This is the digital brain that orchestrates the entire wash cycle. It decides how much water to use, how long to soak, when to spin, at what speed, how to drain, and even when to unlock the door. And no, it's not just timing. It's constantly monitoring inputs from sensors all over the machine to make real-time decisions. Take water flow, for example. You don't just get hot or cold water pouring in like a faucet. Inside your washer are solenoid valves, electromechanical gatekeepers that control the inflow of hot and cold water. Based on your selection and sensor input, the brain tells these valves when to open, how long to stay open, and in what ratio. It adjusts the mix for delicate cycles, tougher loads, or energy-efficient eco modes. Some high-end models even use flow meters to count every drop. Now imagine your washing machine filling up and the clothes just floating there. Not very helpful, right? That's where the drum kicks in, the heart of the washing mechanism. The inner drum, where your clothes go, is suspended inside a larger outer tub. And the engineering behind this suspension is insane. It's essentially floating on shock absorbers, just like a car's suspension system. These dampers reduce vibrations when the drum spins at hundreds or even thousands of revolutions per minute. Without it, your washer would bounce across the room like a runaway robot. The inner drum is connected to a powerful motor, usually an induction motor or in newer models, a direct drive inverter motor. Direct drive motors connect directly to the drum without belts or pulleys, giving smoother control, less noise, and more precision. These motors can reverse direction, ramp up speed gradually, and maintain consistent torque through the cycle. All of this is dictated by the software brain we mentioned earlier. But here's where it gets even smarter. Your washer doesn't just hope you loaded it right. It knows. Weight sensors beneath the drum calculate the load before washing begins. Based on the detected weight, the machine decides how much water to use and how fast the drum should spin. If it detects an unbalanced load, like when you stuffed in a heavy blanket on one side, it will try to correct it by rotating the drum slowly and redistributing the weight before starting the high-speed spin cycle. And speaking of spinning, have you ever heard your washer sound like a jet engine taking off? That's centrifugal force at work. The spin cycle can reach speeds of up to 1600 RPM, creating a force that squeezes water out of clothes through the tiny holes in the drum. The machine must maintain perfect balance during this phase, otherwise, the vibrations could damage internal parts or even the floor beneath it. That's why many machines have gyroscopic sensors that detect even the tiniest imbalance and adjust in milliseconds. Now let's talk about water, because your washing machine is basically a short-term hydraulic system. Water enters, soaks, mixes with detergent, and drains, all precisely timed. The detergent drawer isn't just a tray, it's a carefully engineered path for distributing soap, softener, and bleach at just the right time. Water flows through specific channels, dissolving and carrying the chemicals into the drum based on the cycle phase. Some machines even pre-mix the detergent with water before introducing it, ensuring even coverage over fabrics. Then comes draining. The dirty water doesn't just vanish, it's pumped out using a drainage pump connected to a filter system. This pump is engineered to handle lint, hair, stray socks, or even coins. Some washers pause if they detect a blockage, giving you a warning rather than flooding your home. And when the water leaves, the drum still spins to squeeze out every last drop. We're not done yet. Ever wonder how the temperature stays just right? Washers with internal water heaters can raise the temperature on demand, ideal for killing bacteria or removing tough stains. The heater is often a thick metal coil that sits at the bottom of the outer tub. It's temperature regulated with thermistors, sensors that tell the brain exactly when to heat or cool. Some machines even use fuzzy logic, an AI-adjacent system that learns your usage patterns and adjusts wash settings accordingly. Let's not forget the door. That locking sound you hear isn't just for safety, it's a sophisticated electromechanical latch system. It only unlocks once sensors confirm the water is fully drained and the drum is no longer spinning. Older top-loading machines could be opened mid-cycle, but front loaders rely on this lock for your protection. And here's something wild, modern washers have Wi-Fi modules and IoT connectivity. They can connect to your smartphone, suggest the best cycle based on the laundry load, send alerts when detergent is low, or even schedule washes during off-peak electricity hours. That's a long way from cranking a wringer by hand. Still think your washer is just a dumb box with buttons? Let's zoom in even further. Inside the motor, you'll find copper windings, stators, and rotors engineered to millimeter precision. Bearings must withstand extreme radial forces. Seals keep water from leaking into the electronics. The drum's holes are mathematically placed to create vortexes during spin, enhancing cleaning efficiency. Every component from rubber gaskets to nylon paddles has been engineered, tested, and optimized over decades. Behind every gentle wash cycle is a symphony of sensors. Pressure sensors detect water levels. Vibration sensors control drum movement. Proximity sensors ensure door security. Even humidity sensors help drying cycles in washer-dryer combos. The entire system is designed to operate flawlessly across thousands of cycles, meaning tens of thousands of hours, despite vibrations, heat, water, and detergent chemicals. That's engineering durability at its finest. But not all washers are created equal. Some use agitators, a central post that twists clothes back and forth aggressively. Others rely on tumbling action, where gravity does most of the work. Front loaders are generally more efficient because they use less water and allow for higher spin speeds, thanks to horizontal axis design. Here's a fun twist. Some cutting-edge models now use ultrasonic bubbles to clean clothes. Yes, sound waves vibrating at millions of cycles per second can lift dirt and bacteria from fabric without damaging them. It's called cavitation, and it's the same tech used to clean surgical instruments. In energy efficiency? Washers are tested under strict international standards to measure how much energy and water they consume. Engineers optimize everything from water pressure to motor torque to meet these benchmarks without sacrificing cleaning power. Let's not forget the software updates. That's right, your washing machine can get smarter over time. With firmware upgrades pushed over Wi-Fi, manufacturers can fix bugs, optimize cycles, and even add new modes. It's like a smartphone for your laundry. And now, the future is even crazier. Some companies are developing AI-based laundry recognition systems. Just toss in your clothes and the machine visually scans the fabrics, colors, and weight, then picks the right cycle for you. Others are experimenting with robotic arms that load and unload laundry, or washers that recycle water internally to reduce waste by up to 80%. Still wondering how something so mundane got so high-tech? Your washing machine is a stunning example of how centuries of mechanical innovation, electrical engineering, and digital evolution can converge into one everyday object. It's a device we use without thinking, yet it embodies some of the most complex interdisciplinary design on the planet. So the next time you hit that start button, remember you're unleashing a carefully choreographed dance of water, power, pressure, and precision. A robot that scrubs, spins, and soaks while adjusting in real time to give you the perfect wash, because when it comes to engineering marvels, the future isn't always in outer space, it's spinning quietly in your laundry room.